Welcome to Study Loop.
Okay, so I see that you need help with this question, and it says the gas miles in miles per gallon of 25 randomly selected sports cars are listed in the accompanying table. Assume the mileage assume the mileages are not normally distributed. Use the standard normal distribution or the t distribution to construct a 90% confidence interval for the population mean. Justify your answer. If neither distribution can be used, explain why. Interpret the results. So first of all, there is 25 randomly selected. It's a 90% confidence interval. Okay, so the first thing that you have to do is you have to calculate your mean and your standard deviation for the data set. So the mean for this data set is 22.36. And the standard deviation for this data set is 3.365. And so now you're ready to calculate your t-score. So to get your t-score for a 90% confidence interval, you're going to do 1 minus 0.9, which is 0.1. And then you take 1 minus 0.1 divided by 2, and that is going to be 0.95. So then what you're going to do is you have your t-score, 0.95. Degree of freedom is 24. And looking at your chart, it's going to be 1.7109. So you're going to take the mean of 22.36 plus or minus 1.7109. You're going to multiply that by your standard deviation of 3.365, and you're going to divide that by the square root of 25. So you're going to take 22.36 plus or minus 1.7109 times the 1.7109 times, and then 3.365 divided by the square root of 25 is 0.673. And then when you multiply these numbers together here, you're going to get 1.1514. And so the confidence interval is going to be anywhere between 21 and round to one decimal place. So 21.2, comma 23.5. So it says let the standard deviation be the population standard deviation and let n be the sample size. Which distribution should be used to construct the confidence interval? So I don't know what these drop down menus say. However, blank be used to construct the confidence interval since blank identify the confidence interval. So if your standard deviation is going to be the population standard deviation, then you're going to use the z-score. And so z-score is going to be 1.645. So my calculations are going to change a little bit. So if you have to use that, then the difference is you're going to take the 22.36 plus or minus 1.645 times 0.673. And so it'd be 22.36 plus or minus 1.645 times 0.673. And that is 1.107. So 22.36 minus 1.107. And so that is still 21. Well, it's going to be 21.3, comma. And then if I add the two numbers together, I'm going to get 23.5 still. So either way, it's going to be very similar. So 21.3, comma, oops, that's a 2. 3, comma, to 23.5. And then it says, interpret the results. So with 90% confidence, it can be said that 90% of all random, that most sports cars in population have a gas mileage that are between the intervals of, because you said that the mean mileage of all sports cars is between, okay, so it's actually A. With 90% confidence, it's not B. It can be said that the mean gas mileage of all sports cars in miles per gallon is between the interval endpoints. So I hope that this video helps. This is a teacher signing